Okay, so this is the very last thing in this unit, okay? The mole equation is going to involve a little bit of math, but it's easy, okay? It's just algebra. It's like grade 7 or 8 algebra, okay? Just being able to manipulate an equation. I'll go over how that works, okay, when we get to that point, okay? But the purpose of the mole is to act as a unit of measurement, okay? So a mole acts like a unit of measurement, like a gram or a liter, okay, or anything else that we would measure, okay? It represents a certain amount of a material. So it's a unit for measuring the number of particles. Okay? The reason we use the mole is because atoms are really, really what? They're really small. Okay? It would be impossible to physically count the number of atoms that would be in a chemical reaction because they're really, really small. And even in an incredibly small amount of matter, there would be an incredibly large number of them. So many so that you would probably spend your life counting them. Right? So we can't do that. So what we do instead is we use some of the numbers from our periodic table. Okay? And those numbers would be what we call the atomic mass. So if you look at your periodic table, okay, you'll see atomic masses listed in each box. Okay, like for hydrogen, for you it's 1.01. Okay, for lithium it's 6.94. Okay, that's telling you the mass in grams of 1 mole of that material. Okay, so that's the atomic or molar mass of that material. Now you're probably thinking, okay, well, what's a mole? Last time I heard the word mole, it meant that little rodent that burrows under the ground. Okay, well, it's not that kind of mole. Okay, this is a chemistry mole, and a chemistry mole represents this: 6.02 times 10 to the 23 particles, whether they're atoms or molecules. Okay, so that's how many atoms or molecules of a material are in 1 mole. Is that a big number? Okay, that's 602, with 21 zeros behind it. Okay, so it's an unfathomably large number, right? You would never be able to count to that number, okay, before you were old and gray. All right, so the mole measures the amount of something, okay? Because everything has different atoms, the molar mass of everything is different, okay? Because if I have 1 mole of hydrogen atoms are very small, so that it wouldn't have a lot of mass. Whereas conversely, if I had that same number, 1 mole of lead, okay, it would be much heavier because lead atoms are much, much bigger, okay? And in fact, 1 mole of lead has a mass of 207.2 grams, okay? Much more than the 1.01 grams of hydrogen. All right, so that's what we're going to be looking at today. How do we use the mole equation, okay, and stuff like that. All right, so we can express the amount of something in either grams or moles, okay? So when we balance an equation and we put those coefficients in, okay, those coefficients can represent the number of moles. I would need 1 mole of this, 2 moles of that, and on the other side I would get 2 moles of this and 1 mole of that. Okay, that's what those coefficients that we put in can represent. Okay, they could also be as simple as I need 1 atom of this and 2 molecules of that, and I'll get 2 atoms of this and 1 molecule of that on the other side. Except that if that reaction happened where it was actually just 1 atom and one molecule, would you ever notice? It'd be too small. Okay, so most of the time, those coefficients that we use in balancing a reaction actually represent the number of moles of the material you would use. Okay, all right, so like we said, we can't possibly count the number of particles, so we use a representative number, in this case, the mole. Okay, the mole works like a dozen. Okay, how many do you have? You have a dozen of something. 12. Okay, it doesn't matter what you have. If someone says you have a dozen of these, you know you have 12. A dozen always represents 12. Whether it's donuts or eggs or whatever, okay, it's always 12. Well, a mole is always this many. And it doesn't matter what I'm talking about. Whether I'm talking about chlorine gas, water, a chunk of lead, okay, whatever, okay, if I have 1 mole of that material, this is how many particles of it I have. Okay, so it always represents the same number. Okay, now that number was arrived at through a lot of experimentation. Okay, it wasn't just randomly picked. Nobody would randomly pick a ridiculous number like that. Okay, so this was arrived at through a lot of experimentation. Okay, basically Mendeleev, the guy who developed the periodic table, okay, came up with this, with the idea of the mole. Okay, and what he did, okay, is he found he wanted to figure out what how many particles would be in 1 gram of hydrogen, because hydrogen was the simplest of all of the atoms. Okay, and he wanted to come up with this representative number. So he said, I'll use the simplest material, okay, and I'll be able to figure out the mass of 1 atom of this material. Okay, but that was possible because we had a pretty good idea what the mass of 1 proton was and what the mass of 1 electron was. And that's all that makes up hydrogen, so it would have been pretty easy to figure it out. Okay, and what he found was, if he had 1 gram of hydrogen, there would be this many particles. Okay, that's where he got that number from, which is also why the molar mass of hydrogen is so close to 1 gram. Okay, because he was actually off a little bit in his calculations. That's why the number's not exactly 1 gram. Okay. All right, so this, okay, Mendeleev kind of came up with the periodic table. Avogadro is the guy who came up with the actual experiment to determine the number. Okay, so this is Avogadro's number. That's 6.02 times 10 to the 23. Okay, that's Avogadro's number. Avogadro is, well, he called it the mole. When I show you a picture of Avogadro, you'll know why. He looks like a mole. He doesn't have a big mole. He looks like a mole. If you've ever seen what a mole, like that's what a mole looks like, Avogadro looks like that. Okay, a lot. It's uncanny. Okay, it's got to be his spirit animal or something. All right, so that's what we're going to look at here. Okay, so the mass of 1 mole of a substance is known as a substance's molar mass. If we're talking about an element, we just read it off the periodic table. Okay, if someone tells me or asks me what's the mass of 1 mole of calcium, I would say it's 40.08. Okay, I can just read that right off of my periodic table. 40.08 grams would be the mass of 1 mole. Right? What if I want to figure out what the mass of 1 mole of a compound is? Add them up, exactly. Okay, so if I'm looking at water, for example, okay, so water has 2 hydrogens and 1 oxygen. Okay, if I want to find the molar mass of that, what I do is I find the molar mass of hydrogen, which is 1.01. Okay, and how many hydrogens are there? 2. So I multiply that by 2. Okay, and then I add that to the molar mass of oxygen, which on your periodic table is 16. Okay, and so what I get is that the molar mass of water is 18.02 grams per mole. Okay, so that means if I have 6.02 times 10 to the 23 molecules of water, it'll have a mass of 18 grams. Is that very much water? No, it's 18 milliliters. Okay, because 1 gram of water has a volume of 1 milliliter. Okay, so that would be 18 milliliters. It would fit almost in the cap of a water bottle. Okay, that would have 6.02 times 10 to the 23 molecules of water would fit in the cap of a water bottle. Okay, gives you some idea just how small they really are. Okay. All right, is that making sense? How we would calculate the molar mass of different compounds? Okay, we'll try a couple here. I'll just make up a few and see if you guys take out your periodic tables and see if you can figure these ones out. Okay, try those 2. Okay, so let's quickly have a look at these ones here. All right, so if I've got potassium nitride, okay, I've got to take the molar mass of potassium and multiply it by 3. Okay, so potassium is what, 39.10? Is that right? Okay, so we got 39.10, okay, multiplying that by 3, and then adding that to the molar mass of nitrogen. okay, which is 14.01. There's only one nitrogen, right? So if I do that, okay, then I'll have my molar mass. Okay, so I'll have 39.1 times 3 plus 14.01. All right, so 131.31 grams per mole. Okay, how important are units? Very important. Okay, if you do not include units on an answer, it's wrong. Because I don't know whether it's apples, oranges, elephants, old ladies and walkers. I don't know. Okay, you got to put units on there, or I don't know what you're talking about. Okay, second one. I've got triphosphorus pentasulfide. Okay, that's my compound there. So now I need to figure out its molar mass. So I'm going to take phosphorus, 30.97.
Yep.
Okay. So 30.97, and I'm going to multiply that by 3 because there's 3 of that, and I've got to add that to 5 sulfurs, 32.07. Mind like a steel trap. Okay, times 5. Okay, and then put them together. So we'll have our 30.97 times 3 plus 32.07 times 5. Okay, so we've got a molar mass there of 253.26. Grams per mole. Okay, is that pretty straightforward? All right. It gets a little more complex if you have a polyatomic ion with brackets. Okay, because then you got to do all the, okay, so there's a 3 inside the brackets and a 2 outside the brackets. That means there's how many, okay, you got to be able to do all of that when you're doing these calculations. Kind of like in these examples right here that you're going to do right now. Okay, I want you guys to calculate the molar mass of each of these. So obviously they get progressively more difficult. Okay, so let's have a look at these ones here. So our first one, we've got sodium chloride. How many sodiums in this? How many sodium? 1. How many chlorine? 1. Okay, so we're going to go 22.99, okay, grams per mole. That's the molar mass of sodium, okay, plus 35.45, which is the molar mass of chlorine, okay. So when we add those two together, okay, so 22.99 plus 35.45, and 58.44 grams per mole. Okay, so that's our molar mass for sodium chloride, right? That one's pretty easy. Okay, number 2, okay, we got iron and 3 bromines. 1 iron and 3 bromines, so we got 55.85. Okay. Okay, so that's our 1 iron plus the bromines, 79.9 times 3. Okay, so 55.85 plus 79.9 times 3. Okay, so 295.55. Grams per mole. Okay, questions on that one? Okay, then for number 3, okay, we've got diphosphorus pentaoxide. So we've got 2 phosphorus, so 30.97 times 2 plus 16 times 3. Sorry, times 5 times 3. Okay, so we got 30.97 times 2 plus 16 times 5. So 141.94 grams per mole. Okay, how many people are done 4 and 5? Okay, we can do more time on those? Okay, I'll give you a couple more minutes, then we'll go on 4 and 5. So 4 and 5 don't work any differently than any of the other ones we've done. We just have to do a little bit more work to figure out how many of each atom we have in order to do this. Okay, so when I'm looking at this compound, which is ammonium sulfate, okay, I have nitrogen, I have hydrogen, I have sulfur, and I have oxygen. Okay, now the ammonium is in brackets, and there's a 2 outside of the brackets. So how many nitrogen atoms are there in this? 2. Okay, so I'm going to go 14.01 times 2. Okay, that's how many nitrogens I have. Okay, how many hydrogens do I have? 8. 8. 2 times 4 is 8. Okay, so we go 1.01 times 8. Okay, how many sulfur do I have? Just 1. Okay, so 32.07. Okay, and how many oxygen do I have? 4. Okay, 16 times 4. So that's really all there is to it. And it's no different than what you have to do when you're balancing an equation. Right? You have to do basically the same thing when you balance a chemical equation. Okay, so it's really not anything new to you. Okay, so we're going to have 28.02, that's our 2 nitrogens. Okay, plus 8.08, that's our 8 hydrogens, plus our 1 sulfur. Okay, and our 4 oxygens. All right, so we're looking at 132.17 grams per mole for that. Okay, questions there? And then for number 5, okay, I've got scandium carbonate. Okay, so I've got scandium in here, I've got carbon, and I've got oxygen. How many scandium are there? 2. I cannot remember what the mass of scandium is. 44.96, is that what you guys have? Yes. Okay, times 2. How many carbon are there? 3. Okay, so there's my 3 carbon, 12.01 times 3. And how many oxygen do I have? 9. 3 times 3 is 9, so 16 times 9. All right, so we're going to take our 44.96 times 2 plus our 12.01 times 3 plus our 16 times 9. All right, so we're looking at 269.95 grams per mole. Okay, everybody all right with those? Okay, so that's one of the things that you'll have to do when you're solving a mole equation problem. You'll always have to calculate the molar mass of the material that's being asked about. Okay, and that's how you do it. You just use your numbers from your periodic table. All right. Now, when we look at a balanced chemical reaction, okay, what the balanced chemical reaction is telling us is the number of, most of the time, moles of each material. Okay, because we can't deal with the small numbers of it's 1 molecule of nitrogen reacting with 3 molecules of hydrogen to make 2 molecules of nitrogen trihydride. We would never see that reaction. It's too small of an amount. Okay, but if we were talking about 1 mole of nitrogen gas reacting with 3 moles of hydrogen gas to produce 2 moles of nitrogen trihydride gas, okay, that would be different. That would be a big enough reaction that we would notice it, we'd be able to measure it, okay, things like that. All right, so we can interpret it from a number of different ways. Okay, we could say that, like we said, it's 1 mole. Okay, or it could be that there's 28 grams of nitrogen and there are 6 grams of hydrogen. Okay, and that's going to make 34 grams of nitrogen trihydride. Incidentally, same amount of mass on the reactant side as there is on the product side. Okay, that's the law of conservation of mass, right? I can't create matter and I can't destroy it. So whatever the mass of my reactants is, that's the mass of my products as well. Right? And when you get into Chem 20, if you decide to take Chem 20, the first thing that you will do in Chem 20 is what we call reaction stoichiometry, which is doing exactly this, using the mole equation and stuff to calculate the amount of mass on one side versus the amount of mass on the other. Okay, so you'd be predicting how much, what mass of material you could produce using a reaction. Okay, when you get onto university, you actually get graded on that. Okay, so if you're taking chemistry in university, when you do a lab, they grade you on the percent yield that you get. So you run this reaction, and then you measure how much of the product you get, and it's based on the percentage of the reactants you used. Okay, if you get anything less than 90% yield, you basically fail. Very sticky about that. If your lab starts on fire like mine, you fail. True story. Somebody set it on fire, we found out later, but it wasn't me. Anyway, so that's what we're kind of looking at there. Okay, so we said we could look at this from a particle perspective. It's one particle, okay, or it's two particles or whatever, okay, or we could look at it from a, oh, that's got him. I told you you look like a mole. He's got the big eyes and like the tiny little nose, and he's got like no shoulders. Now, I'm sure it's just the cut of the suit, but it looks like he has no shoulders, and moles, which burrow in the ground, don't have much for shoulders because it would make it hard to. Anyway, okay. So the other perspective, and most of the time when we balance a reaction, we look at it from the perspective of how many moles of each material, okay? But we can also look at it from a mass perspective, okay? And so that would be the third one. The third way is to look at it from a mass perspective. We don't do that in Science 10 anymore, but I did change my notes, so it still includes that. Okay, so here's the mole equation. The mole equation is N equals little m over big M. Because, chemists have to be difficult. Okay? They have a 3-variable formula, and in our alphabet we have 26 letters. They used one of them twice in the same formula. And the only other letter they used is the one that sounds like the letter they used twice. N equals m over m. Okay? So, here's what we have to know. Okay, we have to know what each part of this represents. So N, okay, is the number of moles. Okay, so N represents the number of moles of the material. Okay, M is the mass of the material, and that's always going to be in grams. Okay, so little m, okay, lowercase m, is the mass of the material in grams. Capital M is the molar mass. That's that thing we just learned how to calculate from the periodic table. Okay? And its units are always going to be grams per mole. Okay, so this formula works when it's set up. Okay, we would calculate the number of moles by dividing the mass we have in grams by the mass of 1 mole. Okay, if we divide the mass we have by the mass of 1 mole, it should tell us how many moles we have. Agreed? Okay, so that's how that formula works. Okay, it can also be used or manipulated to solve for mass. If I knew how many moles I had and the mass of 1 mole, what would I do with those two numbers to get mass? Yeah, switch them in and multiply, right? If I know I have 2 moles and 1 mole equals 5 grams, I would go 2 times 5 grams, and that would tell me the mass of 2 moles. Are you okay with that? Okay, so you just did algebra. So I'm going to show you how you manipulate this equation. You're never going to have to manipulate it for capital M, because you always calculate capital M using your periodic table. Okay, that's molar mass. You'll never use this formula to calculate it because you always calculate it off of there. So you probably learned somewhere along the way, okay, that there's like little tricks for manipulating. Forget those tricks. They suck. Okay? And I'm just putting that out there right away, especially this one. Whoever taught you that, not good. Okay? You should never, ever, 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 ever use a triangle to manipulate an equation. You're better than that. Okay? You don't need this thing to help you do math. Also, this thing will stop being able to help you do math in 1 more month. Okay? When I give you this equation. There's no triangle that'll work for that one. And not a trapezoid or a rhombus or any other stupid shape that you can think of will work for that equation. Okay? And it only gets worse. Okay? You get into physics 20. I challenge you to find a triangle for that one. Okay? There isn't one, okay? Because triangles suck.
Sorry.
And I wish to punch very hard whoever keeps teaching how to use triangles. Okay? Because it sucks. I know who it is. Okay. We got to be able to do algebra, guys. Algebra's not that hard. Okay? If I want to manipulate this equation, okay, right now it's solving for n. If I want to manipulate to solve for m, okay, I have to move big M. Right now, I'm dividing by big M. If you want to move something in algebra, you do the opposite. So the opposite of divide is done. You just manipulated that equation the only way you will ever have to. Did you need a triangle for that? No! You didn't. Because triangles suck. And you won't use them anymore. Okay? All right. Okay, so rules of algebra, guys. Easy rules of algebra. If I want to move something, I do the opposite. And when I do to one side, I do to the, that's really all you need. There's a third rule, but I'm not going to teach it to you yet. It's not any harder, but you don't need it yet. Okay, so if we can remember those rules, we're fine. So when we moved this m over, really all we did was multiply both sides by m. That made the m cancel over here, and it appeared over on this side. That's all we did. Okay, that's the only manipulation of that equation we're going to have to do. All right, everybody okay with that? All right. We are going to go through. There's only 4 ways for me to ask a mole equation problem. Okay, 4 ways. I'm going to go through all 4 ways today. I'm going to go through all 4 ways again tomorrow. I'm going to go through all 4 ways again on Monday. No, I'm going to do a unit exam review on Monday. Then I'm going to go through all 4 ways again on Tuesday. Okay, and you'll get all 4 ways a few times. Okay, so you'll see them all and you'll have recordings of all 4 ways.
Is all 4 ways going to be on the daily quiz?
On Tuesday?
Yeah.
Yes. Okay. And obviously on the unit exam. Yeah. So we got to know how to do it. Okay. But it's pretty cookbook. Like once you learn the pattern, it's really not that hard. Okay. All right. So I want you to write this one down because this will be our first example. We want to calculate how many moles of calcium chloride are in 90 grams. Okay. Okay. So whenever we're doing problem solving in science, the first thing we want to do is write down our givens. That is, what numbers or values did the question tell me? Okay? So the first thing is it asks me how many moles. What part of the mole equation represents moles? N. Okay, so N is not given to me. It's the thing I'm being asked to find. Okay? The other thing it says is it's for calcium chloride. What can I use that to find? That we just practiced a minute ago. Big M, right? Molar mass, right? So I'm dealing with calcium chloride. So I can calculate the molar mass of this stuff right now, okay? Calcium is 40.08 grams per mole. Okay? Chlorine is 35.45 grams per mole. And there's 2 of them. Okay, so when we do that, we're looking at 110.98. Don't be impressed. I just remember it. I didn't really just do that in my head. Okay. So there, I've got now my molar mass. And what's the other thing they give me? 90 grams. That's little m, because little m is mass in grams. Okay, so if you do that, calculate your molar mass, write down your givens, that's 1 mark. Okay, if I'm marking this on a quiz or a test, that's 1 mark. You wrote down your givens and calculated your molar mass. Okay. The question wants us to calculate N. Okay, do I need to move anything around in my equation or is it already set up? Already set up. Okay, so you get 1 mark for having the formula you need to use. That's an easy part because you didn't have to do anything with it. Okay? Usually at this point, I'll also give you a mark for plugging in the numbers into the correct places. I'm pretty generous with marks, so you definitely want to show your work. Okay? So we're going to have 90 grams divided by 110.98 grams per mole. Now you don't always have to write the units in on this part. Okay? All right, now looking at that, do I have less than 1 mole?
Yes.
Yes, because 1 mole is 110 grams and I only have 90 grams. So is it okay if I get a decimal?
Yeah.
It is, it's less than a mole. Okay, just sometimes people are intimidated by that. They think they did something wrong. Okay, so N equals, so we're going to take our 90 grams and divide it by 110.98. Okay, so we have 0.81 moles. And we abbreviated MOL because we're really busy. Okay, we don't have time to write out the whole word. You laugh. Our society has an abbreviation for the word at because we're too busy. Okay, come on, we have an abbreviation for everything. LOL. Okay. All right, so everyone kind of follow how that one worked. Okay, that's the easiest one because you don't have to manipulate anything, everything's given to you. All right, okay. Anyone need that one anymore? There you go. Okay. All right, I want you to write this one down. Okay, and we'll walk through this one. All right, so for this one, same first step. We want to write down what the question gives us. So the question is saying, what is the mass? That means we're looking for little m. Okay, wants to know the mass, so we're looking for little m. Okay, it's telling us that we have 4.5 moles. So what did it just tell me there? Big M.
Big N.
N. Right. Okay. So N is 4.5 moles, and then it tells me that this stuff is magnesium bromide. That helps me get big M. Now, it gave me the name in words. Do I need to get the formula right in order to get this question right? Yes, if I don't drop and swap this ionic compound, I will not get the right answer for this problem. Okay, so I've got magnesium with bromine. Okay, magnesium's a +2, bromine's a -1, so I'm looking at MgBr2. Okay, so magnesium's 24.31. All right. Yeah. Okay, and it's with bromine, 79.9, and there's 2 bromines. Okay, so that's how I would calculate my molar mass. Okay, so my molar mass is 184.11 grams per mole. Okay, so I need to calculate M this time. Okay, so my initial formula is N equals little m over big M. All right, and I need to move some stuff around so that I get M, little m, by itself. All right, so I've got to move big M over here. All right, so I'm going to multiply both sides by big M. Okay, and that's going to leave me with little m. All right, so you'd get a mark for that manipulation, and you'd get a mark for plugging in your numbers correctly. 184.11 times 4.5. So there's big M and there's M. All right, so that's going to get us our mass in grams. Okay, so we'll take that and we'll multiply by 4.5 moles, because that's the mass of 1 mole. Okay, 184.11 is the mass of 1 mole. We have 4.5 moles. So that means we have 828.50 okay, grams. Everybody all right with that one? Okay, so the first two just involve using the mole equation. The second two ways that I can ask a mole equation problem involve Avogadro's number. Okay, that's 6.02 times 10 to the 23 that you probably forgot about. This is where it comes back. Okay, now remember that that's 6.02 times 10 to the 23 is the number of particles in 1 mole. Right? So the next two questions are going to ask us to do one of two things. Either calculate the number of particles, or they'll give us the number of particles and ask us to calculate the mass. So it's going to combine using Avogadro's number with the mole equation. Right? So it's just like one small extra step that will go on to these two types of questions. Okay. So copy this one down, okay, and we'll go through it here in just a sec. So how many molecules are in 600 grams of silver nitrate? So same idea here, okay, we want to write down what our givens are, okay? So we're looking for how many molecules, okay? So okay, that's our question mark. That stands for number, by the way. It's not hashtag molecules, okay? That number, that symbol used to stand for number. So we're looking for the number of molecules in 600 grams. So what did they just give me there? Little m, right? 600 grams. And they tell me that it's silver nitrate, which means I can figure out what the molar mass is. Okay, so silver nitrate, Ag, which is a +1, is with nitrate, NO3, which is a -1. So that compound dropped and swapped. Looks like that. Okay, so now I can calculate its molar mass. All right, so silver's 105.95. No, 107.87. Way off. 107.87. Okay, there's only one of it. How many nitrogens are there?
Or no, one.
One. Okay, because that little 3 only applies to the oxygen, right? Okay, and so there's 3 oxygens. Okay, so we've got 107.87 plus 14.01 plus 48. So 169.88 grams per mole. Okay, so that would be your first mark there. Now, I'm trying to calculate the number of molecules. Right now I have little m and I have big M. What can I calculate with those two things?
Little, or just M.
N, right. I can calculate the number of moles when I have those two things. So that's my next step. Calculate what N is. All right, so I'm going to go N equals little m over big M, because that's all I can do right now. Okay, maybe that'll lead me toward the number of molecules. Okay, so I'm going to have little m, which was 600, divided by big M, which was 169.88. Okay, so we have 3.53 moles. Now, I'm only going to write 3.53 here on the board rather than writing all the decimals, but you should keep all the decimals in your calculator. Whenever you're doing a multi-step calculation in science, keep your decimals. Okay, put it in the memory of your calculator, okay, or go back and copy and paste it down. Okay, you need to keep all the decimals until the end when you round. Okay, so you always keep everything. It's more accurate than rounding off, especially with what we're going to do with this number next. Okay, so now I know the number of moles. Okay, the question wants to know the number of molecules. So I know the number of moles, and I know that this number is the number of molecules in 1 mole. Okay? So let me ask you this. You have 2 dozen donuts. How many donuts do you have? 24. How did you do that?
12.
Right. You took the number of dozen you had and you multiplied it by the number of things in a dozen. 2 times 12. Well, you're going to do the same thing here. Okay? Here's my number of moles. here's the number of molecules in a mole. If I multiply those two numbers, it'll tell me the number of molecules. Okay, it looks a lot different. It looks like it's way harder than that how many dozen donuts, or how many donuts do you have in 2 dozen, but it's exactly the same calculation. Avogadro's number is like 12. Okay, and this, okay, is your number of dozen. Okay, this is your 2 dozen, this is your 12. Okay, you're going to multiply them together and calculate the number of molecules. Okay, so you got this many moles, this many molecules in a mole, multiply the two numbers, and you've got your number of molecules. Okay, so number of molecules is always n times Avogadro's number. Okay, Joe.
Why don't we just use the answer to Avogadro's number instead of write 6.02 times 23?
What do you mean the answer to Avogadro's number?
Like what 6.02 times 10 to the power 23, the answer to that.
Be a long number.
Yeah, it's really long. I'm going to show you how to punch in your calculator. Okay, because it's way quicker than punching in 0 21 times. Yeah. Okay, so this is what we're going to do then. We're going to put in our 3.53, and we're going to multiply it by 6.02 times 10 to the 23. In your calculator, this is how that works. Okay, if you have, how many people have the TI monster? Okay, some of you. If you don't have that, your calculator has one of 2 buttons. Okay, it either has a button that has 2 capital E's on it, or a button where that's the second function. Okay, or it has this button. Okay, it'll have one or the other. Even your phone's calculator has it if you flip it on its side. Okay, I think the Apple one does it. Okay, that's what that button does is it takes your 6.02 and then you hit the EE or the EXP, and that represents this times 10, and then it says the next number entered is the exponent. Okay, so you press this button and then you enter in the exponent, which is going to be 23. Okay, so on a TI it looks like this. You put the number, you have to put the number in brackets. If you don't, your calculator will do some weird order of operations thing that you don't want it to do. Okay, so I put a bracket here and I go 6.02, and then on the TI, the EE is the second function on the comma. Okay, so I hit second function, comma, okay, and I get an E. Then I put in 23. That's Avogadro's number entered on the TI 83, or 84, or 85, or whatever number we're on now. Okay. If you have a different calculator, you're going to do the same thing. You're going to go brackets 6.02 and then hit one or the other of the EE button or the EXP button, and then 23. Okay. So that's how we enter that, and then we're going to multiply that by 3.53. Actually, 3.53. I'm just going to put in my answer from before, because I said keep all the decimals, right? So times my answer. Okay, so that's all those. Okay, so it's telling me that in this 600 grams, I have 2.13 times 10 to the 24 molecules. Okay, so I would write this out as 2.13 times 10 to the 24 molecules. Okay, that's how many molecules are in 600 grams of silver nitrate. So this one works backwards. They're telling us, here's the number of molecules. What's the mass? Okay, so how much mass is there if I have this many molecules of this particular compound? So we're actually going to almost do the reverse of what we just did a minute ago in order to solve this one. All right, so I'll give you a sec to get that written down, and then I'll walk you through it. Okay, so this one gives me the number of molecules. Okay, it's 1.54 times 10 to the 25, so definitely more than a mole, Okay, and they tell me that it is diphosphorus tetraiodide. Okay, so P2I4. Okay, so I can calculate the molar mass of that. So we'll have 30.97 times 2 plus, what was it, 126.90 times 4. Okay, so we're looking at 569.54 grams per mole. Okay, so I have the molar mass, and they're asking me to calculate mass. Okay, so if I'm going to calculate mass, little n, I need big M, which I have, and I need N, which I don't have yet. Okay, I don't have it yet. But I can calculate it if I do this kind of a calculation. You have 36 eggs. How many dozen do you have? 3. What did you do? Right, you had 36 divided by 12. You took the number of eggs you had and divided by the number of eggs in a dozen. Well, we're going to do the same thing here. Okay, N is going to equal the number of molecules divided by Avogadro's number. Okay, so that's going to look in this question like this. 1.54 times 10 to the 25 divided by 6.02 times 10 to the 23. Okay, I'm taking the number of molecules I have and dividing it by the number of molecules in 1 mole. That'll tell me the number of moles, or N. And then I'll be able to go back and calculate the mass. Okay, so how does this look in your calculator? It looks like a lot of brackets. You need to use a lot of brackets. If you don't, your calculator will do order of operations and mess everything up for you. Okay, so when I'm punching this one in, okay, I'm going to go bracket 1.54 times 10 to the 25. And I'm going to divide that by Avogadro's number, separate set of brackets. Okay, so just the operation I have here written out on the board, that's what it looks like entered in my calculator. Okay, all enclosed in brackets. Okay, so I have 25.58 moles of this material. Okay, that's what N equals. 25.58 moles. Okay, so now that I know N and I know big M, can I calculate little m? Okay, all I have to do is move big M over here, okay, and I'll have little m. Okay, so little m is going to equal N times big M. I now have both of those numbers, 25.58 with all the decimals, okay, multiplied by my 569.54. All right, so I'm going to take that number with all the decimals and multiply it by 569.54. Okay, is that a lot?
Yes.
Yes, it is. That's 14.5 kilos of this stuff, whatever it is. Okay, diphosphorus tetraiodide. I don't even know what that is, but it's a lot of it. It's 14.5 kilograms. That's about 30 pounds. Okay, of it. Okay, so for this one here, okay, we can write out that whole thing, 14,569, or we can put it in scientific notation, which I'll talk about another day. I've given you enough math to worry about for one day. Okay, so 14,569.63. grams. Okay, there's only 4 ways I can ask you a mole equation problem, and now you've seen all 4. Tomorrow, I'll go through all 4 again. Okay? I'm going to go through all 4 again 3 more times. Okay? Okay, so you'll see it lots of times before you have to write your unit exam on the 19th, which is next Thursday. Okay, so it's a week away now, okay, until we do that. Okay, so that's the mole equation stuff. Like I say, we're going to be working on that tomorrow. We'll work on it again on Tuesday. Monday, I'm going to go over the unit exam review, and I will post the unit exam review package today. Okay, so you can have a look at that over the weekend. Now, just so you're aware, the unit exam review package contains a couple of things. Okay, some suggested activities, okay, and some questions and stuff to try with the answers, and a practice test that is exactly like what you're going to write on Thursday of next week. Old multiple choice questions that I don't use anymore, okay, and some old written response questions that are basically that I don't use anymore, but it's the same skeleton, okay? That practice test that you're getting, I use the same skeleton, I just put different muscles on it for yours, okay? So do it last though, okay? Don't do the practice test first. If you do it first, all it's going to tell you is you need to study more, okay? If you study some and then do the practice test, it'll tell you you don't know how to do this or this, and you'll know what to go over some more, okay? All right.